Okay. Maybe one more quick example. Actually, I'll do one more example, but I'll do it in two different ways, where I'm just going to try to plot the graph of a line based upon an equation. And so if I get an equation like, I don't know, 6x minus 3y is equal to maybe 9 or something like that. Let's try that one. 6x minus 3y equals 9. That's the standard form. And so if I wanted to solve this for y, I got to first subtract off the 6x. Again, remember these are unlike terms, a constant and one with an x. So I get negative 3y equals negative 6x plus 9. Got to keep them separate. Again, it could be 9 minus 6x, but I want to put the x first so that it's in this form. And then I'm going to divide out the negative 3, and I'm going to divide it to every term. Okay, it distributes to every term. And so my y is equal to negative 6 divided by negative 3 is positive 2 times the x. And then 9 divided by negative 3 is a minus 3. So I get the graph, or I get the line y equals 2x minus 3. And so to graph that, let me come back and get rid of some of this so we can actually plot that one. To plot that one, let's see, I always start with a y-intercept. You have to start with a point and then use the slope to go from there. So I'm going to start with a y-intercept of negative 3. So 1, 2, 3, 4 maybe. So right there, that is going to be 0, negative 3. And then from there you use the slope. Well, here the slope is a whole number, which is kind of weird. M is 2, B is negative 3. But if you notice that the 2, always want to write these as fractions so you can see the rise over run. And so as a fraction, 2 is really 2 over 1. Terrible looking 2 right there. Yeah, 2 over 1. And so the rise is 2, the run is 1. So that means you go up 2 over 1. Up 2 over 1, that gives you a point at 1 comma negative 1. And you can continue this pattern on from there. Again, you go up 2 over 1. That would put us at a point 2 comma 1. And you could just keep going. You could also go down 2 back 1. That would also give you, right? So you could think of it as a negative 2 over a negative 1. Gives you 2 anyway, right? So down 2 left 1 would put us over here at negative 1 comma negative 5 if we wanted to. And so I can draw the line through those points, assuming I actually line this up correctly. There, not too bad. I can adjust it as needed. So a little bit curved, but good enough. So that gives you an idea of how to plot the graph using the slope-intercept form. Now there's another way, actually a lot of times it's easier to use the x and y intercepts and not actually have to solve for the slope-intercept form. So to do that, you might, actually let me get rid of these and I'll keep that so I can categorize this. So what I might do is start with the, oops, let's go with blue for the x-intercept. Start with the original equation. Let the y value equal 0. So it's always, you always use the opposite variable as 0. So if the x-intercept, I want y to equal 0, and then I solve for the x. X is what I'm solving for. So I'd have 6x minus 3 times 0 equals 9. The term that has the 0 always drops out. I'm left with 6x equals 9. Divide both sides by 6. My x is 9/6, which if I reduce that by 3, I get 3 halves. 3 halves is 1.5. So my x-intercept should be 1.5. If I plot that right there, That makes sense, right? It's about where it lines up. And so I have a point on the graph at 1.5 comma 0. So this is an alternate to using the slope-intercept form. So I'm doing kind of an alternate method. I wouldn't already know this stuff. I wouldn't already have the graph here. I'm just plotting from the 2 points, the intercepts. So if I find the x-intercept, plot it. If I then find the y-intercept, I'll do that in green just to change up the color here. The y-intercept is found when the x is equal to 0. Remember, the opposite variable is 0. And then you solve for y. So I'd have 6 times 0 minus 3y equals 9. 6 times 0, 0. Negative 3y equals 9. Divide out the negative 3. And y is negative 3. 9 over negative 3. And so my y-intercept would be 0 comma negative 3, which is right here. And we already knew that one, but again, I'm pretending that I don't know this already. All right. And so once I find the x-intercept and the y-intercept, I can just plot the line through them. It'll match up, perfectly coincide with the line I already have here. Okay. All right. Now, the last thing, last two things that I really want to mention are the function notation. Something that might be confusing. And you'll often see this where we take the slope-intercept form and we replace the y with something called function notation. Basically, it's a notation here. We call it f of x. It's f parenthesis x parenthesis. And it gives us an idea of an input-output relationship. You plug numbers into a function and you get an output. It's like putting money into a vending machine and getting out a pop, right, or a candy bar. You put something in, you get something out. A function, a mathematical function, is similar, where you plug in numbers and you get out other numbers. And so here, the numbers you plug in are the x, the numbers you get out are the f of x, the function of x, or the y values. And so, for instance, if I wanted to find, maybe f of 2, that implies your input is an x value of 2. So you have, now I'm going to go ahead and I'm going to use this, here it is. I'm going to use this equation. So it's 2 times 2 minus 3. So I'm going back to this guy and putting it into function notation. So 2 times 2, the x is 2, minus 3, which is 4 minus 3, which gives me 1. And so my output is 1. And that makes sense here. I have an input of 2 and output of 1 on the graph. So I would say that f of 2 is equal to 1, and that corresponds to the point 2 comma 1 being on the graph, okay? And so you can do that for any point. You plug in any point, you get an output, and the input shows up in the parentheses. That kind of makes sense, right? Input in parentheses, and the output shows up on the outside, all right? The other thing that I have left to mention here, and that is when you have those vertical and horizontal lines, the slope-intercept form is a little bit different. You don't quite have the same form of an equation. If you think about for a moment what would happen in the case where you have a horizontal line. It's a horizontal line. We said that the slope is 0 for a horizontal line. It means it rises 0 and runs whatever you want. Well, if I plug in a 0, I get y equals 0x plus b. Well, the 0 term drops out, and you're left with just an equation y equals b. So the equation for a horizontal line is always y equals a number, and that number is going to be the height of the line where it goes through the y-axis, okay? So if you wanted to plot y equals -5, well, that one's just because it's y equals, it's a horizontal line, and it's at -5. So 1, 2, 3, 4, 5. So that's -5 down there, and it's going to run horizontally. This is my x-axis. I should label these more carefully. That's my y. and my line y equal -5 is horizontal, okay? Vertical lines are a little bit different. A vertical line it doesn't even have a slope. The slope is undefined. It doesn't exist. And so the equation is completely different. But what we end up with is the equation, so m is undefined. And what we'll end up with is the equation where we just swap y with x, because these are going to be x value, the fixed x value. And the b, which was the y-intercept, changes to a, which is the x-intercept. So it's x equal a. A is arbitrary. It does stand for arbitrary, but a doesn't have to be a, but whatever it is, it's the x-intercept. It's the constant value for all of the x values. So if I wanted to plot the equation x equals 7, it's going to be a line whose x values on every point is 7, right? X values are 7. And so you go over 7, 1, 2, 3, 4, 5, 6, 7, and you plot the line vertically, because at that point, every single x value at every point in that line is 7, okay? And the x-intercept is 7. So that's the line x equals 7. So if x equals a number, it's vertical. Y equals a number, it's horizontal. And that should cover everything. There's a lot of information here with equations of lines, but they're very important to really, hone in on these ideas, the different forms of a line, the different shapes or directions, and how to plot a graph using either the slope-intercept form or a combination of your intercepts.